Good. Good afternoon. Welcome. So, my name is Veen, and I'm the director of the Science Education Institute in New Jersey. And over the past 2 years, I've spent all my time looking carefully at new standards that we're developing and helping teachers implement these standards in the classroom. So, and what I would like to share with you is why these standards may be important for other countries in the world, and particularly for countries in the Middle East. So, I don't know if other people will join us during the session, but if they will, they'll post it for you. So this is what I'm hoping to talk about. One is, why do we need new science standards? Second, what is the framework on which these standards are based? And this framework is what is important, because the framework is not tied to the standards. So the framework is something that could be used in any other country to develop their own standards. Third, I will talk about how the framework was used to develop the standards and what the standards look like. I'll give you some examples of what students should be able to do as part of these new standards. And then finally, what are the implications for these standards across the world? Now, I don't want to talk for a whole hour, so I'll make it a little interactive. I'll make it a little bit interactive for you. So let's talk about the need for new science standards. And I actually would like to ask you these two questions. And you can talk with somebody who's next to you. So why do you teach science to your students? And what do you hope they will learn? So take a moment to talk with each other about these two questions. And if you need to move, you can move yourself. Okay, so let's take a moment to share out. So why, I can ask you, why do you teach science to your students?
Well, I try my best that my students can relate everything that they learn in science to everyday life processes, like why is this happening, why there's gravity and all of that, and try, if they have any problem, try to solve it out by somehow following the scientific method, like draw a hypothesis, think about it, think of ways of solving it, try to find a solution for it. So everything basically is related to science.
So the important point was made is we want students to relate science to the world around them, right? Because to make sure that they understand that science is relevant. So who has something else to add? Yes.
We teach students science to help them to understand what happens around them and to understand the nature.
Yes. So we want students to understand the world around them and how it works, and also the nature of science, how it works. So anything else? Yes.
It actually helps us to acquire skills. Our students to acquire skills, and also to be inquirers all the time, and not to take facts.
So That's another important piece. We want students to develop skills that comes with doing science. That's an very important part. So let's think about how well we're succeeding in doing this. And in general, what we find in the United States is that the old standards are not meeting the new requirements. So in the United States, new standards were developed, new national standards. They were developed about a year ago. They were developed initially as part of science, math, English, and social studies, which is basically history and geography. But science felt that they needed to go a little slower and not directly go to standards, but build a framework initially. But I'm stressing the connection to the math and language arts standards because they have something in common that is really important. And that is that we're moving in education from knowing information to applying information. All our education, everything that I experienced in school, probably what you experienced in school, was all about, do you know the information? But that's not enough. Not anymore. So we need to move from knowing information to, can you apply it? Whether it's in reading, in any language, writing, in math, or in science. So before the standards were written, scientists, educators, college educators worked on a framework. And this is the framework. You can download this framework on the internet. It's from National Academy Press. So this framework was used to develop the standards. It incorporates everything we know about how students learn science. And a couple months ago, I was talking to a teacher, and she said, why are we changing standards? Because the brains that we have didn't change, so why do we need to change things? And I said, you're right, our brains have not changed. But what has changed is what we know about how our brains work, especially related to young children. Young children, 5, 6, 7-year-olds, are much more capable than we thought they were in the past. So, and then finally, it's not just about how students learn, but the demands of the 21st century are very different from the past. So students need a different education to meet those demands. And that is taken into account in creating this framework. So what's the main message in the framework? If I had to summarize it in one slide, it's this slide. And it says that we need to move away from one-dimensional learning, which is focused on just the content, which is we call here disciplinary core ideas. And we need to include science and engineering practices, which are the things that scientists and engineers do to learn about science, and we have to bring those into the classroom. And we have to also bring in cross-cutting concepts. So those are scientific ideas that go across the sciences, like patterns or energy. And they have to work together. They're not a separate class, they're not a separate course, they're intertwined and part of the learning. That is the key idea. And the reason that I think this is relevant in the Middle East or anywhere on earth is because this framework can be used to develop standards in other places. And I will talk about that more later. So let's look at these dimensions in a little bit more detail. So this is one of the dimensions that's stressed in the new standards. They're called science and engineering practices. And they're more than skills. They're not skills, they're practices because they have no meaning without content. They always go with content. And you can read them. There's 8 different ones, but this is what students are expected to do. Right? So this is not the teacher asking questions. This is the students coming up with questions. The students developing models. The students planning investigations. But I want to switch for a second, and it goes back to what you said, is science teach skills that we need outside of science. So let me ask you the question. If I look at developing and using models, in what jobs, non-science jobs, do you need to develop and use models in the 21st century? What jobs? Sorry?
Medicine.
Medicine. So in medicine, we use models, right? To develop medicines. We use models to figure out what happens when we apply medicine. So, but that's still sort of science. Any other jobs where you use or develop models? Computers? And any other jobs? Simulations? That's what models are. So, simulations of what? What can we simulate in the real world? Traffic, right? We can simulate traffic. What about economy? We have to develop models of the economy. So my point is that this practice, developing using models, can be applied outside of science. So what about this one? Analyzing and interpreting data. In what job do you have to analyze and interpret data? Everywhere. Everywhere. Because if you run a store or a company and you can't analyze your data, then your company won't exist right now. Right? So that's an important skill. What about obtaining, evaluating, communicating information? You think that's important in the 21st century? So my point is that these practices were included in the standards because if we apply them to science, we deepen students' understanding of the science. But in addition, outside of science, they help us become more productive citizens, whether it's in our private lives or in our working lives. The second dimension is the cross-cutting concepts. So you recognize some of these as ideas that are valid in biology, life science, earth and space science, physical science. And again, I want to ask you the question, how are they important outside of science? So patterns. Are patterns important in other jobs in addition to science? What jobs? Economists look at patterns. Who else looks at patterns? Architects. Who else? What other jobs? Geologists. Right? Weather forecasters. In fact, if you analyze data, you said before, when you analyze data, everybody has to analyze data, whether you're a scientist or not. What's the first thing you do when you analyze data? You look for patterns, right? You look for patterns. So patterns is important. What about systems and system models? So let me ask you, what is a system? I'm switching. Okay, so what is a system? What is a system? A group that act together to accomplish something, right? So you have systems in nature, and we have systems that we build. So this microphone is part of a system. Part of that system is over there. And there's a battery in there somehow. Because if it wasn't, then it wouldn't work, because it needs an energy source. So, in what jobs do students have work with systems? Where do you have to have an understanding of systems? Politics, biology, science, but politics, what else? Schools, computers, right? Companies. So, again, systems, I'm just picking random parts here. All these cross-cutting concepts are important, not just in science, but also outside of science. And then finally, energy and matter. And this is is what I find important. So I'm going to school, and my teacher tells me that energy is conserved, right? We all learn this. But then I open the newspaper, and somebody else tells me that we have an energy problem. How can we have an energy problem when energy is conserved? So every person in the 21st century needs to be able to answer this question. And the answer is, of course, that once you have energy in a concentrated form, like a battery, and you make a circuit and a light bulb, the energy is used, the light comes out of the light bulb, and it spreads out. It's not concentrated. It's still there, it's conserved, but it's not concentrated and you cannot use it. So when we develop hybrid cars, we actually find a way to collect that energy. But the understanding of this idea in biology, in physics, in chemistry, in earth science is critical, not just for scientists, but for everybody. So again, my point is that both the practices and the cross-cutting concepts have a validity and an importance outside of science. And then finally, content. So things have changed. When I was in school, many, many years ago, if I want to know something, I have to find a book. And most often have to go to the library to read it. And I have to go to many, many books to find that information. So when I went to schools, the teachers tried and helped me memorize the information. So I had it in my head. And I'm not saying that you should not know anything, but your advantage in knowing something is very small because the next person gets their phone out and can find it. So it's not enough to know the information, we have to be able to apply it. And what we need to think about in science is what is the core knowledge that we need to learn further. And I want to give you some statistics and some data in addition to what you heard this morning. I read 10 years ago that if you graduate from high school, you know 4% of everything you need to know. Only 4%. And it doesn't get much better after college. In other words, when you leave college, you have to continue to learn. Here's some other statistics. In the US, when I left college, I can expect to have 2 jobs, 2 careers, which is true. I was an astrophysicist in the past, and now I'm a science educator. Any student who leaves college now has 4 different careers. Students who are in lower elementary school right now, who will graduate in 10, 15 years, are expected to have between 10 and 12 different careers. We have to prepare them for them. So the question becomes, what are those core ideas in science that can be building blocks for further learning? And as strange as it may seem, the focus is on less content, but deeper understanding, rather than covering so many details and everything is the same importance. And I have to say, when I say this to teachers in America, everybody smiles and says, yes, we want less. Until they find out that their lesson and the topic they teach, they don't have to teach anymore, because it's their favorite topic. So that is, in a nutshell, this framework. And there is a lot more information, I'm just summarizing. So how did we develop standards based on this? And what does that look like? And this is just an example, and other countries can do it in a different way. So first of all, the framework said, if you are serious about 3 dimensions, content, practices, and cross-cutting concepts, you have to make sure that you will assess them and test them together. Because the testing, unfortunately, is the way we tend to teach. If we're only testing on content, we're never going to teach the other dimensions. And then the second thing is that the standards should be restated in terms of performances. So if you look at old standards in the US, and I don't know what your standards look like, they say that students should know this, or students should understand that. These practices are different, and I'll show you some examples, but they're examples of performances. So, the framework was finished in 2011, and then teams of teachers in 26 states in the US worked together to develop these standards. And they went to 2 public reviews. I was one of the reviewers, and where teachers and the public were giving comments. And I want you to look at some of this information here. Is even in the last go-around, 95% of the standards were rewritten, and 1/3 was removed because teachers said it's too much. You can't teach it all. So they removed additional standards to limit the scope. So what does this look like? And I wanted to give you some examples. So I want you to look at these standards, and this tells you at what age students should be able to do what. And this is going to be tested. So read this slide and think about, can your students do this? But also, what would be the benefit if your students could do this? So take a look. I'm going to forward to the next slide. So this is older students. So take a moment to talk to the person next to you. So what would be the benefit to your students if they could do this? What would be the benefit? You know? And then, how well would your students be able to do this if you asked them to do this now? So take a moment to talk about this. So what would be a benefit if students could do this? What would be a benefit for these students? It helps them to be creative. Thank you. And productive. And those are 2 important words. Productive is an important word, right? Because if you can be productive, then you can make a living for yourself. But creative is also a very important word. And we think of artists, painters to be creative, but scientists and engineers are very creative. They come up with solutions to problems that we can't even imagine. And it's very, very important. Any other advantages? Yes? Yes?
Last year and this year we are working on the NGSS to modify our science standards. And definitely when we were working on that, before we started doing this, we realized that there are many things missed in our science standards. The connection that was between one grade and another, skills that develop and build up. So it's they construct knowledge and they construct also ways of thinking, critical thinking, and it was very successful. I have to say this. We based our standards on this.
That's
and
great.
We're still working on the performance and the practice and the time.
Thank you for sharing that. And I have to be honest with you. I'm telling this to teachers in the US. To implement this, to make this work in your school takes many, many years. It's not an easy process, but it's where we need to go. That's where we need to go if we want to make our students successful. So you can read this page, but I want to show you what the standards look like. If you open the book of the standards, there's 80 pages. 80 pages of standards. It starts in kindergarten, 5-year-olds, and it tells you exactly, in kindergarten, this is what we're doing. First grade, second grade, all the way to 5th grade. And then it has bands, 6th to 8th grade, and 9th to 12th grade. So what is on this page? At the top, and we'll go and look at that in detail, are the performances. It tells you what students should be able to do as a result of their teaching. The middle is the content. And the content is 3 parts. The practices, we talked about that, the practices. The science ideas, the core ideas, and the cross-cutting concepts. And those 3 were used to create the performances. And I will give you some examples of that in a minute. And teachers love this, especially in the US where elementary schools, teachers teach math, science, and English together. The connection between those 3 topics is often lost. But at the bottom, it shows the connections within science, across grades, within science for different grades, and also connections to math and language arts, which is English, in the Common Core. And it's all there, so we can see how doing science helps us with math and helps us with English. And then in addition to the standards, these are all the support documents. If you look at this, it talks about how do these standards help students become ready for careers in college. It talks about number D, diversity and equity. In other words, these are not the standards for the top students. They're the standards for every student. And it talks about different course maps. It talks about the overlap with the math and the language arts. So I want to dive a little deeper and show you what the performance expectation looks like and how it was developed. So here's an example. And this is middle school. It says, develop and use a model to describe how the total number of atoms does not change in a chemical reaction, and thus mass is conserved. So a student on a test needs to do this. It's an interactive computer-based test, not multiple choice. It adds a clarification, which is very important because sometimes people don't understand what this means. And it says, the emphasis is on the law of conservation of matter, on physical models or drawings, including diagrams that represent atoms. So now we know what we mean with this. And there is an assessment boundaries, which says that this is what is on the test, and this is what's not on the test. And the assessment boundary says the assessment does not include the use of atomic masses, balancing symbolic equations, or intermolecular forces. So all this helps clarify to the teacher what is expected. Now, that performance expectation has 3 different parts, and I'll show you. The first part is develop a model, develop and use a model to describe. Where does that come from? Well, that comes from the practices. Because there's a practice, developing and using models, that said that students should be able to develop a model to describe something you cannot easily observe. So that's pulled in to that content. Then the second part is, from the content, they pulled out that the total number of atoms does not change in a chemical reaction. And then from the Crosscutting Concepts, they pulled out that the total number of atoms does not change, and therefore the mass is conserved. So you see that in the performance, the content, the cross-cutting concept, and the practices are combined. And that is true for every single performance expectation. Every single one, on every single page. And on the state test, students have to perform this. They have to be able to do this. It's a big, big shift. So, what are the implications for the rest of the world? Well, let me tell you something about America. I didn't grow up in the United States. I grew up in Holland. So when I came to the United States, I was very surprised. Because in Holland, the government says, this is what we're doing, and everybody does it. It's the same in Jordan. It's not true in the United States. The United States is basically 50 countries. And as far as education is concerned, who get to decide what they do in education. So, even though we have these national standards, each state gets to decide, are we going to adopt them or not? This has never happened before. In the past, states would take the standards and write their own. But in the last year and a half, all the states in green, including New Jersey, where I live and work, but including also a big state like California, adopted the same standards. It's unique. It's unique. The other states in orange, they're still considering these standards. There's one state who's decided not to use it, and the other ones we don't know what's happening. So they're making these decisions. But the same thing may be true for other countries across the world. Because I am convinced that standards across the world needs to be updated to prepare students for the 21st century. The question is, do we all want to do the work again from scratch, or do we want to build on what other people have done? So here's some possibilities. One is, you change your standards, but you just change it. You just change the words and delete them or add them without a framework. It's not what we did in the States. We decided to build a framework first and then rewrite completely the standards. But that's option one. The second option is you develop your own framework, which is that you go into write, you get your best scientists and teachers, and you write this. Look at all the research, you create the framework to build the standards on. That's the other option. Another possibility is that even though you may be in Jordan or Saudi Arabia or any other country, you could use this work that has already been done, that's based on research about learning across the world and the needs of the 21st century, which is global, and use this to revise your own standards. You could also use this and then use it as a guide to look at the American standards and make decisions if parts you want to use or parts you don't want to use. Or finally, you can also adopt both. But there are going to be cultural differences across the world. So somewhere along this line is, I think, the choices that you have. But it's clear, I think, that standards across the world will need to change if we want to help our students be competitive across the world. So here's some resources. If you want to learn more about these standards, a couple things you need to write down. One is the National Research Council has a website, www.nap.edu. You can go to that website, give them your email, and you can download this book as a PDF for free. In fact, you can download much of the research in education for free. As PDFs, you don't get the book. You have to pay for that, but you can download it for free. Another place is www.nextgenscience.org. This is where the science standards are published. You can download all the standards and all the appendices. There's no commercial value to that, so they're free to download. Then the National Science Teacher Association in the US spent a lot of time developing resources for teachers. They have webinars for teachers, which is wonderful because you can watch it here. You can watch it anywhere in the world. You can have webinars on practices, cross-cutting concepts. There's probably about 30 webinars right now, and new ones are coming out, and they all are archived. So you can watch the webinar from 2 years ago. There's articles, there's journals that you can download, and the membership is not limited to the US. You can become a member, and the journals are electronic. So these are wonderful resources for you if you want to learn more about these standards and think about what is the option to use them in your schools, in your programs, in your country. So I want to end with asking, what questions do you have? So if you listen to this, what questions do you have about this or any questions? That is the critical question, which is, now we have standards, but now what is going to happen in the school? How do you apply this? And I have to say, I'm going to be honest with you, we're trying to figure this out. Because that's important, because this is just paper. We have to make it real. And I can tell you what I think. Teachers need training. You cannot give the teachers a book and say, okay, we have new standards, go teach it. They need training because these standards reflect a way of science teaching that is new for all of us. So one of the things I do is I work with teachers. In fact, I like what they said before, that the best thing is to have teachers teach teachers. So I work with leader teachers, a small group right now, 8 leader teachers that we want to expand to 100, who are trained and help facilitate workshops, and they go back to their districts and they work with other teachers to help them implement these standards. But there is still lots of unanswered questions of what is the best way to get teachers to teach this. It's a very good question. And ultimately, you as teachers, you are part of the answer. I mean, the answer doesn't always come from the top. The answer often comes from those of you who work in the field. There was another question here and then.
Did you find a difference between this standard and our standard in general? Or maybe we are about this?
I have to say, I've worked in Jordan for 3 years as part of the Queen Rania Teacher Academy, and I worked with the science networks, 2 science networks. So I've seen some of the standards. I think the difference is similar as in the US, which is that the focus is very much on content and not a lot on the process. And the other thing is that these standards are changing the way we think about income. And I want to give you an example. What has happened in the last 20 years is we said students should not read about science. They should do hands-on. And hands-on became a way to get to the content. So we said, for example, the density, we said, okay, we don't want you to read that density is mass over volume. Instead, you measure mass, you measure volume, you divide it, and now we're learning to teach you about density. But actually it doesn't work, because students didn't learn what density is. These standards think differently. They say, look at phenomena, things that we can observe. For example, if I go in my house in the summer, and I go upstairs, it's warm. Upstairs it's warm. And downstairs it's colder. Why is that? Now, there's a lot of different reasons, but one of the reasons is that air, when it gets warm, is less dense and it goes up. So the idea is to look at phenomena, things that we can observe around us, and apply the science. That's where we have to go. And that integration I don't think it's in the Jordanian curriculum, the parts that I've seen, and it's not in the US curriculum either. I mean, it's not anywhere. But it's a good question. You had another one, and then Sumaya. Yeah.
I'd like to comment on both questions because we passed this experience and we still working on
Yeah.
the standards. When we work at school, we work that these standards are aligned with the education standards. The content is actually, as was mentioned, the content is there, but we need to find alignment. What goes with the education standards. And on the other hand, in terms of implementation, it should come from the teachers. And if you can get the teachers come together and discuss it together and tell them, ask them, where do you think you can do something here? What can you do here? Can you just try to plan the lesson and give us something, what suits our school, what does not suit? And simply, they did a great job. The teachers and both heads of sciences, not coordinators, actually comes from the teachers. It's feasible if you can implement them, but you have to work together. And teachers have to work together and come with ideas.
Yes, I can't agree more with you, but it also means that teachers need time to plan together, right? And I have worked with teachers in Jordan. I know that that's not always possible. I mean, sometimes teachers have multiple jobs, so that's policy decisions. But planning together is critical. That's wonderful. That's wonderful, but it depends on the school. Again, I want to stress, these are standards for everybody. We cannot, in the 21st century, you cannot leave out anybody. This cannot be standards just for the elite schools. They have to be standards for all schools. But sometimes, one thing, if we can get it to work in one place, it may help us learn how to get it to work in another place. Sumaya, you had a question?
Sumaya, want to ask which is or are the most sensitive standards to cultural difference?
I don't know. That's a good question. That's a good question. So,
because if you want to choose one of the approaches, how to look at our standards, the slide before. No, the one before. Change or looking at them in the light of the standard. When you want to go through any changes, depending on the standard, the one you are working on, you see that there is the cultural differences is the things that in preventing adopting the standard as they are. مش بس sorry.
Yeah, I think that if you feel, and I know there's cultural differences, so then one option would be, I would say, look at the framework, and then see if you can recognize things in the framework that would be culturally difficult here, and then work from there, and then that may affect your standards. Even in the US, we have differences. And there are some sensitive topics in the US that some states disagree with. One is evolution, and the other one is global warming. Right? These are evolution and global warming are two topics where in politics we disagree. So,
Global
and that
warming, how global warming is a dilemma?
Because in the US, in some states, the politicians do not believe that global warming is caused by us, by humans. But these standards teach that this is real part of this problem. So, I want to thank you for being here. I want to thank you for asking questions. I don't want to be in between you and a coffee break, so enjoy your conference, and thank you for coming.